All right, good morning and happy Wednesday. Hope everybody is doing well on our e-learning day. Today we are going to talk about our last new material for Indicator 12. So this is Indicator 12.3 or Day 3. And we're going to be finding the range when we're given the domain. Okay, so you will want to get your 3-ring binders out. You will want to put down these examples. There's, let's see, 6 examples, so it won't be bad. All right, so first thing I want to cover is just a quick recap. Look at our directions here, and oops, it says right here, these are our directions. Find the range given the domain for each question. Well, if we remember, right, our range, right, is our y, and our domain is our x. So let's right? So range is just a fancy term for y, and domain is a fancy term for x. So what this means is we need to find the y's when we're given the x's. Well, we've done this before. We're just going to make a t-chart. So if we make our little t-chart here, all right, we're going to make our t-chart. And this is our x's and our y's, or our domain and our range. Remember, x is the same as our domain. All right, so if we're given the domain of -2, -1, 0, 3, right? That's our domain. We need to find the range. And so we need to find all the values of our y every time we plug in an x. Well, we've done t-charts before. So we're going to work this problem or this equation 4 different times. And each time we're going to plug in a new value for x. So let's do it first with this -2. So if we do y equals 3 times -2 plus 2. Okay, that's y equals 3x plus 2, and in place of x, I'm going to put the -2. So now if I evaluate, 3 times -2 is -6 plus 2, and -6 plus 2 is -4. So when x is -2, y is -4, or when the domain is -2, y is -4, or the range is -4. So now we're going to do the same thing, and this time, in place of x, we're going to put -1. So 3x plus 2, and this time for x, we're going to put -1. 3 times -1 is -3 plus 2 equals -1. So when x is -1, y is -1. Now we're going to do it with 0. So y equals 3, x is 0 plus 2. Well, 3 times 0 is just 0, and 0 plus 2 is just 2. So when x is 0, y is 2. And then last, we're going to take y equals 3x, which this time we're going to plug in a 3 plus 2. Well, 3 times 3 is 9 plus 2, and 9 plus 2 is 11. So we filled in the t-chart. Now I want you to look at this part of the instructions I have underlined. It says write your answers as a set of ordered pairs. And we also know that a set of ordered pairs is called a relation. So we're going to write our answer as a set of ordered pairs. So for our answer for number 1, I'm going to do it right above it just because I kind of don't have enough space inside my box. So I'll just put a text box right above it. All right, so our relation, okay, is going to look like, sorry, I put my pencil in my mouth, makes it kind of hard to understand me. All right, so I'm going to use a text box just because for me that's a whole lot neater than trying to write it, but you, of course, if you have room in your box, you can write it. So my answer as a set of ordered pairs is, right, let's do that in black. All right, so the first point in my relation is -2, -4, right? Here we go. -2, comma, -4, because when I plugged -2 into my function, I got out -4. So that is an x and a y. The next x and y is -1, -1. So -1, -1 is an ordered pair. Okay. Next, I have 0, 2. So 0, comma 2. That's my next ordered pair. And then my last ordered pair was 3, 11. When I plugged in a 3 for the x, I got 11 for the y. That's my last ordered pair in my relation. So I close out the brackets. And this right here would be your answer. So this right here in the box is all the work that it took to get the answer. Always watch your directions about how they want your answer given. So they might want you to just state the range, right? And if on this one, if we were just asked to state the range, it would be r equals, and there are fancy brackets, -4, -1 to 11, right? That would be just stating the range. In this case, they ask us to write our answer as a set of ordered pairs, which is why I wrote our relation up here. So when you're done, go ahead and put a circle or a square around your final answer, so that we know that that is actually your final answer that you want to circle and get credit for. Okay. All right. So next we're going to do number 2 as an example. And if you need to, I'm going to go ahead and put a square around that as my final answer, because my direction said to write my final answer as a set of ordered pairs. All right. So number 2. Okay. I'm going to go back to my pen here. Number 2 says that my domain is given -4, -2, 6, and 8. And so I'm going to go ahead and write my t-chart here with my x's and my y's, right? X is your domain and y is your range. And so I'm going to plug in the domain they give me here is -4, -2, 6, and 8. So for every one of these, you're going to have a t-chart. You're going to fill in your domain or your x's, and then you're going to work the problem however many times you need to in order to get the corresponding y's. So we've got y equals 1/2 times, the first x we're going to use is -4 minus 2. Well, 1/2 of -4 is -2 minus 2 equals -4. So when our x is -4, our y is -4. Now we're going to work it again with -2. So we do y equals 1/2 of, our next x we're going to plug in is -2 minus 2. Well, 1/2 of 2 is 1, and a positive and a negative is a negative. So that's -1 minus 2 equals -3. So we'll plug -3 in here. And then we're going to work it again. 1/2 of 6 is minus 2. And so 1/2 of 6 is 3 minus 2, and 3 minus 2 is 1. So we can put a 1 in there. And then I'm going to have to erase some of this because I'm kind of out of room here. So pause the video if you need to catch up with the work I've done so far. And then I'm going to erase this here and work the final domain value, which is 8. Oh, there's a quicker way to do that. Let's do this. All right. So the last one I'm going to plug in is 8. So you've got y equals 1/2 times x, and in this case the x is an 8 minus 2. 1/2 of 8 is 4 minus 2, and 4 minus 2 equals 2. So you'd fill in that last, oh, I forgot to write them in there. So that was a -4, and that was a -1. I think I erased those. 1/2 of -2 is -1. Let's see. I think I erased my values here. So let's rework them here. 1/2 of 6 is 3, and 3 minus 2 is 1. And 1/2 of -2 is -1, and -1 minus 2 is -3. And 1/2 of -4 is -2, and -2 minus 2 is -4. There we go. Hopefully I did that right in the video. All right, so now I have got my x's found, or my given x's, and I've got all my y's found that go with each x. So now I'm ready to write my answer as a set of ordered pairs, because that's what the instructions want us to do. So our set of ordered pairs here is, there's my fancy bracket. The first one is -4 and -4. My next one is -2, -3. My next one is 6, 1. And my last one is 8, 2. And there is my answer, given as a set of ordered pairs, also known as a relation. Okay? All right. This time I'll try not to erase the values in my T-chart when I get it done. All right. So this time, same thing, right? We do it the exact same way. We give ourselves a T-chart here. And our domain, which is our x's, are given. And our domain here is -5, -1, 0. Okay, so I'm going to make that a little bit shorter since I don't need it quite so long there. All right, so we're going to work this problem 3 times because we're given 3 x's here. So the first time through is 2y equals 3 times x, which is a -5, minus 1. So 2y equals, well, 3 times -5 is -15, minus 1 is -16. And remember, I'm solving for y, so I have to divide off this 2 and divide off the 2, and I get y equals -8. So I can plug in -8. Okay, pause the video if you need to catch up with the work, so I'm going to erase this here. And it deletes my -8 every time. That's what happened last time. So let's put that -8 back in there. Okay, so now we're going to work it again, and we're going to go 2y equals 3, and in place of x, I'm going to put a -1, minus 1, and 2y equals 3 times -1 is -3, minus 1. So 2y equals -4, and then I divide by 2 and divide by 2, and I get y equals -2. So I can plug a -2 in here. Okay? And now I'm going to erase this a different way here so I don't take out my answers this time. Give me just a second here. All right, so last we're going to plug in a 0 into our equation. And this one will be a little bit easier. So if we plug a 0, we've got 2y equals 3 times 0 minus 1. 2y equals, well, 3 times 0 is just 0, right? 0 minus 1. So 2y equals -1, and then I divide by 2 to get my y by itself, and I get y equals -1/2. So when x is 0, y is -1/2. And now we're ready to write our answer as a set of ordered pairs. So the first ordered pair is -5, -8. The second ordered pair is -1, -2. And our third ordered pair is 0, -1/2. And then that is our ordered pairs for this one. So -5, -8 is an ordered pair. That's an x and a y. -1, -2, and then 0 and -1/2. All right, finally on this last example, and we're going to definitely need more space here, but that's okay. We'll make it work. We're going to plug in, got our x and our y, make our T-chart. We're going to plug in -4, -2, 0, 2, and 6. So this time we have 5 given in our domain. That means we have to work our equation 5 times. In example number 3, we only had 3 in our domain, so we only had to work the example or the equation 3 times. So for every domain or x you're given, you're going to find the corresponding y. So we're going to do that by plugging in again. So we've got -2x minus y equals 3. And so that's our equation. And what I'm going to do here is I'm just going to remove that x, right? And in place of the x, I'm going to put -4 because that's my first one. So I just took the equation, I replaced the x with our first domain, which is -4, and now I'm going to evaluate it. Well, -2 times -4 is +8 minus y equals 3. So I want to get y by itself, so I'm going to subtract 8 and subtract 8. That gives me -y equals 3 minus 8 is -5. And now I can't have that negative on the y. I need it to be a positive y. So I'm going to divide by -1, which gives me y equals 5. So when x is -4, y equals 5. Okay, I'm going to do the exact same thing again. And this time I'm going to plug a -2. And this one, it'll take just a little bit longer because we are plugging in 5 x's instead of 3 like our previous example. But that's okay. It doesn't get any harder. It just takes an extra minute to do. So let's write our -2, and I'm going to leave a spot for my x, minus y equals 3. And now this time we're going to plug in a -2 because that's the next x. So -2 times -2 is +4, minus y equals 3. And then we subtract 4 from both sides again because we want to get y by itself. And so we've got -y equals -1 because 3 minus 4 is -1. And then again, we're going to divide off that -1. So we get y equals -1 divided by -1 is a +1. So we fill that into our t-chart. Okay, now we can erase this work. And I'm going to get creative here, and I'm just going to erase that goes in a bracket. And I'm going to do the exact same work again, only this time I'm going to plug a 0 in for x. And so in our equation where there was an x, I'm now going to put a 0. Well, -2 times 0 is just 0. It goes away, which is kind of nice. So we're left with -y equals 3. And again, we're going to divide that -1 off. So y equals -3. And then we're going to do the same work. And this time we're going to put in a 2 because that is the next x value that came up in our domain. So we're going to plug a 2 in here. -2 times 2 is -4, minus y equals 3. And then I'm going to add 4 and add 4 because I want to get y by itself. And there's a -4, so to get it off of that side, I'm going to add 4 to both sides. That gives me -y equals 3 plus 4 is 7. And again, right, divide off that -1, and I get y equals, well, 7 divided by -1 is -7. And then last but not least, we work the whole thing again, and this time we plug in a 6 in our x value. And so we repeat the whole process one more time, and then we'll be able to write our answer as a set of ordered pairs. So we're going to plug a 6 in for the x. -2 times 6 is -12, minus y equals 3. I'm going to add 12 and add 12 because I want to break it off of this side, and whatever I do to one, I have to do to the other. So that gives me -y equals 3 plus 12 is 15. Again, divide that negative off, so I get y equals -15. So now I have done all the math required in order to solve each one of my y's for all my given x's. And now this time, when I write my ordered pairs, I'll use the text box again. And when you're actually doing your homework, I don't care which one you use, as long as you write your final answer as a set of ordered pairs. So we've got the first ordered pair was -4, 5. And that's because when we plugged in -4, we got 5 as our answer for the y. And then our next ordered pair is -2, 1. And so you put the soft brackets around each ordered pair, and they are together in those fancy brackets, which means they're a relation. And then 0, -3 was our next ordered pair. And our next ordered pair was 2, -7. So 2, -7. And then our last ordered pair was 6, -15. And then we put the fancy bracket around that to show that that is a relation. So that would be your answer for example number 4. If you have the domain of -4, -2, 0, 2, and 6, you get the ordered pairs that we came up with. And again, if you were asked to state the range, you would just simply state these 5 terms right here because those are your y values or your range. So our range for this function would be -15, -7, -3, 1, and 5 if you were asked to state the range. Okay? All right, we've got 2 more quick examples, and this is testing a theory of whether or not points are a solution to the equation. So for number 5, here's our given equation right here, this 3x minus 5. And what we want to know is we want to check each one of these points, and we want to see if they are a solution. Well, if they're a solution, they're going to make a true statement. if they're not a solution, they're going to make a false statement, and I'll show you what I mean. So look at this first example, this 3, 2, right? That's a coordinate or an ordered pair. That's an x and a y. We have an equation with an x and a y. So in our equation, where there's a y, let's plug in the y value here, which is 2. And then equals 3. And then the x value with this ordered pair is 3. And then minus 5 is the rest of our equation. So that's y equals 3x minus 5, and I've plugged in the x and the y of our first ordered pair. So let's check to see if this makes a true statement. There's nothing over there to do, so that just stays a 2. 3 times 3 is 9 minus 5, and 9 minus 5 is 4. Does 2 equal 4? No, it does not, so that is not a solution. So now let's check the point 4, 6. Well, I'm going to do the same thing, only this time in the place of y and x, I'm going to place the point 4, 6. So in the y spot, I'm going to put a 6, and in the x spot, I'm going to put a 4, because that's the x and the y of this point here. And I'm going to evaluate it. So 6 equals, well, 3 times 4 is 12 minus 5, and 12 minus 5 is 7. Well, that doesn't work out, so that is not a solution. Let's work it again and try the point 2, 1. Okay. All right, so the point 2, 1, the 2 goes in the x spot, the 1 goes in the y spot. 3 times 2 is 6 minus 5. 6 minus 5 is 1. That does check out. That's a true statement, so yes. Whoops, that got messy, didn't it? My dog's upset about something outside. All right, so yes, that one is a solution to our equation. All right, now we work it again. And this time we're going to try the point 0, negative 5. And again, 0 is the x value, so you make sure and plug it in where the x goes, right? The x is right here next to the 3. So make sure that since the 0 is the x here, that the 0 goes in the 0 spot of my equation. Negative 5 is my y, so it goes right here where the y goes. So negative 5 equals 3 times 0 is 0 minus 5. Sorry, my pen shut off all of a sudden. There we go. And 0 minus 5 is minus 5, and so that checks out. So this is a solution to our equation. Now we work it again. You'll notice with these, you have to work it all 6 times in order to answer each one of them, whether or not they are or are not a solution. If they're a solution, they're going to make a true statement. If they're not a solution, they're going to make a false statement. So my point negative 1, 4, well, my negative 1 is the x, so it goes in the x spot. My 4 is the y, so it goes in the y spot. 3 times negative 1 is negative 3 minus 5, and I can already see negative 3 minus 5 is negative 8, so no, that is not a point, and that is not a solution. And then last, we're going to plug in the point negative 2, negative 11. Really, the hardest part for this is just remembering to put your x where the x goes and your y where the y goes. If you can keep that straight, you'll be good. So the negative 2 is the x, so I'm going to put it in here with the x. The negative 11 is the y, so I'm going to put it in the y spot. 3 times negative 2 is negative 6 minus 5. Negative 6 minus 5 is minus 11. Minus 11 equals minus 11, so that is true. So that is a solution. So the only 3 that are a solution is the 2, 1, the 0, 5, and the negative 2, 11. The other 3 are not. All right, last example, and then we are done. Same thing, okay? We've got this equation, and we've got 4, and we've got a spot for the x, plus 3, a spot for the y, equals 9. So our first point is 3, negative 1, and this is the x, and this is the y. Make sure you plug them into the right spot. So this is the x spot, so there's a 3, and this is the y spot, so that's a negative 1. 4 times 3 is 12, and then 3 times negative 1 is negative 3, 12 minus 3 is 9. Does 9 equal 9? Yes, it does. So that point is a solution to this equation. Okay, we're going to do it again, and we are going to plug in the point 2, 0. So this is my x. Oops. This is my x. This is my y. So the x goes in the x spot, y goes in the y spot. 4 times 2 is 8. 3 times 0 is just 0. So that goes away. Does that work? No. 8 does not equal 9. So that point is not a solution to our equation. All right, next we have the point -1, 4. Okay, and you'll notice in this equation, the x comes first and then the y. So I could write them in order. In my first example, like number 5, you had to be really careful that your x goes in the x spot and your y goes in the y spot. All right, so 4 times -1 is -4, and 3 times 4 is +12, and -4 and +12 is 8, so that one doesn't work out. So that is not a solution to our equation. And then we're going to put in the point 1, 2. And when we put the 1 in the x spot and we put the 2 in the y spot, we get 4 times 1 is 4, and 3 times 2 is 6, and 4 times 6 is 10. 10 does not equal 9, so that is not a solution to our equation. And then the point 0, 3, and if you can see it without working it out too, I mean, you don't have to show every little step if you don't want to, but 4 times 0 is 0, and 3 times 3 is 9, and 9 does equal 9, so yes, that one is a solution. You're going to hear my train going by. It'll get loud here for a second. All right, the last one is the point -2, -5. So we plug -2 in for the x, and we plug -5 in for the y, and then see if it works. So 4 times -2 is -8, and 3 times -5 is -15. Hopefully you can already see this one doesn't work out. -8 and -15 is -23. That definitely does not equal 9, so that one is not a solution. So these are a little time consuming in that you have to plug each point in, but it's really the only way to work these problems where you have to check all points and only check the ones that are a solution to the equation. All right, that's all I have for you for today. As always, shoot me an email if you have any questions. If it's a big enough question, I can always open up a Google meeting and we could do a face-to-face chat, and I can help you answer questions. Your homework assignment looks exactly like this, only it's got different numbers, so it should look very familiar to the notes. If you missed anything, of course, you can go back and watch the video. If you still have questions, shoot me an email. I can either answer you via email or we can open up a Google meeting. And then as always, right when I return, we are going to be doing a note check, and I'm going to be checking notes for day 1, day 2, and day 3, looking for all of these examples. So hopefully I will see you all Thursday. That is the plan. And until then, stay safe and make good choices.